Hello, I'm Jeremy Leipzig, and I'm Senior Product Manager at TileDB, the multimodal database designed for discovery. Today, I'm going to show you how to transform raw data into reproducible results with TileDB Carrara. Typical analysis may begin with simply finding required files, such as genome references. In this example, I will register sequence and gene model files located in a remote S3 bucket. Now, these files and folders behave exactly like you'd expect and in a similar manner to your desktop, but you also get searchable metadata and API access, as well as secure sharing and governance. I'm going to add some descriptions and some metadata to these files. Teamspaces behave almost like conference rooms, and you can invite people from your workspace into them and then set appropriate permissions at the Teamspace level. All the actions are audit logged for compliance. I'm going to add a colleague to this Teamspace. Secondary analysis, the long-running file-based transformations typical in bioinformatics, have been revolutionized by pipeline frameworks and workflow languages. TileDB now supports workflows written in the most popular of these domain-specific languages, Nextflow. We've provided two Nextflow modules for TileDB DCF and TileDB Soma that allow users to go from sequence all the way to a queryable database. You can run any Nextflow workflow from the command line on TileDB infrastructure, even remotely, using only a small plugin file. Or you can use this dashboard interface we've set up to preview the functionality for NF Core compliant workflows. Any workflow that follows the NF Core spec can be rendered here as an interactive form, and these can come from NF Core itself, GitHub, or even uploaded from a local drive. I'll import a TileDB specific fork of the popular NF Core strnaseq workflow that produces Soma assets from raw sequence. Okay, now that the workflow has been imported and registered, we are ready to run it. So let's run it from here. You can see, load the parameters. You can see all the markdown content that's in the GitHub repo, part of the NF Core spec has been rendered here. You can see the usage parameters that describe your instructions for running the workflow, all imported and rendered here. And of course, the form itself. So I'm going to fill out this form, and remember we have a couple TileDB registered reference parameters we're going to put in there. we have the ability to actually import sample sheets. They can be in TileDB, they can be in S3, they can even be on a local drive. So I'm going to go ahead and import one that's on my computer. And you can see that's been filled out into this editable form right here. And then we're going to run this, but we're also going to save a manifest. Now, a manifest, workflows are basically blank templates. These are first-class assets in TileDB, and these can be shared. But more importantly, you can share these workflow manifests, which are essentially the filled-in forms. These allow you to maintain a set of parameters and settings for subsequent runs on new samples, for example. So manifests are linked to runs, which are in turn linked to results for provenance tracking. So now that we've kicked off a run, we can actually monitor that run. You can see the raw Nextflow output. That's very helpful for tracking progress from a command line basis. In addition, we can actually see tasks as they are running on the server. In the same fashion, we would see task graphs that were running from a UDF function for tertiary analysis. So you can see runs that are going on in Nextflow that are classified as Nextflow runs. Basically, tasks become high-level task graphs. And you can see the progress there. You can even drill down into individual tasks to see debugging output. We want to make it possible to do development in TileDB, not just running workflows, but debugging them. So when a run is completed, we can preview HTML or Markdown output directly in the browser. And these files are rendered securely even if they contain JavaScript elements. So here we're going to explore some of the Nextflow technical output from this run in terms of an execution report. This would contain helpful information in terms of computational efficiency, such as CPU, memory, task duration. In terms of sequence analysis itself, we have support for multi-QC. So these do contain JavaScript, and these multi-QC report would have individual task information about alignment or raw sequence analysis. So in terms of tertiary analysis, so notebooks, I'm going to show you a notebook that's based around a high-level descriptive statistics on this particular soma. But you should bear in mind that although we're just looking at one run, you can imagine how we typically have a large atlas or a biobank sequencing project where the sample size is growing daily or weekly. TileDB is well suited for this N+1 strategy, and that can include notebooks or dashboards as an automated last step in data generation. So here we see a notebook. This new Carrara notebook interface has been revamped for user friendliness, but it also has a much tighter integration with the underlying file catalog and the file system. One of the nice things I like about this is we have a terminal where we can actually interact more closely with files that live in the file system. For example, I can download reference data directly from the web on the command line and have it appear as a first-class TileDB asset in the catalog. So if I was to browse back to this, to our file system here, you see this file is in fact now an asset that we can interact with and share in the Teamspace. So getting back to the notebook, I want to show you one element I'm excited about, and that's the revamped support for tables. So we now support Apache Data Fusion, So this enables arrow columnar support of representation and includes a Rust API for performance. You've always been able to use SQL to query TileDB assets, but it's exploring the SOMA itself using SQL as a proof of concept. But you can see these aggregations, joins, anything you would do in standard SQL can work with this new Data Fusion API.